All right, number 3. So Walter RFI lifts 281.5 kilograms through 0.171 meters. Okay, so that's the ground here, and he's going to lift it up to here. How much work was done on the object by RFI, assuming it was at a constant speed? So if there's no acceleration, the speed is constant. That means that FA and FG would be equal. So let's call this FA. Yeah, FA, FG. This is going to be the vector, displacement vector D. And we know that work is a dot product of force and displacement. In other words, cosine theta, cosine angle between them. And when we look at these two vectors, they're pointed in the exact same direction, therefore the angle between them is 0, and cosine of 0 is going to be equal to 1. Alright, so let's just plug everything in. FA. We know that the applied force is equal to Fg, so we can just represent it by saying FA equals 281.5 kilograms times the constant of acceleration due to gravity. And then we multiply that by distance, or displacement, which is the 0.171 meters. I'm going to put units in. And we multiply that by 1 for cosine 0. So let's just punch all that into the calculator. 281.5 times we get that the work is equal to 472.2 joules. Joule is equal to Newton meter. So that's one way to look at it, but I'm just going to show you another way. This might be helpful for some people as well. So I've also drawn it like this, where we can say that in the first example here, we're originally saying that he's maybe biting right into the block, but he could also, you could have a rope that goes through the block, and that's a rope right there. And then he's biting the rope with his teeth at this point right here. So if he's biting it there and he's moving his head upwards, he would be applying an upward force to the rope, the FA, and then due to all the weight down here, the force of gravity, because of this mass being large, there's going to be a tension force resisting his upward force. And because of the way ropes work, this from this section, he'd be pulling. This is essentially the tension force by him pulling upwards, but then because there's a force of gravity, there's going to be a tension force downwards. And these are equal and opposite. They're a pair of forces, as usual for tension forces. So another way to look at this would be, well, you can say that these are equal, and if these two are equal, then Fg is still equal to ma, and we'd still have the same equation. It would be the exact same. But then, yeah, this might help us for part B, because for part B, it's saying that what total force was exerted on his teeth. So we can focus on this. We could even redraw this diagram if we want to make it a little bit neater. This is his teeth right there. Mass is 0. We're just going to say there's no gravity or anything due to his teeth. It's just, we just have the tension force. Green. That is going to be equal to force applied by Walter's teeth. So the only force acting on his teeth exerted on his teeth. So this is on his teeth. The F applied, that's what he's exerting, essentially. So this is actually, it's not really a correct way to do that originally. The only thing that's actually exerted on his teeth is the tension force. Tension force, we know that that's equal to this tension force, which is also equal to Fg. All right, and now let's go ahead and calculate that force.